Hello everyone, myself Sunita. This presentation is about quantitative evaluation techniques involved in crude drug analysis. Analysis means knowing the inner details of any item and providing scientific interpretation to these inner details. It includes a method, a series of methods to identify or quantify a chemical substance. These methods are beneficial to know how many different single components are there in a mixture, that is qualitative analysis, and to know the exact quantity of each single compound present in that mixture, that is quantitative analysis. Now coming to quantitative evaluation techniques. There are majorly divided into two type of techniques: instrumental methods, non-instrumental methods. Instrumental methods, they make use of various instruments for evaluation like spectroscopy, where UV, IR, NMR, ESR techniques are widely used. Other techniques like chromatography, thermal analysis, electroanalytical techniques are also used for drug evaluation. Non-instrumental techniques are based on measurement of volume or weight of the substance. Spectroscopic methods involves measurement of electromagnetic radiation. They are UV visible spectroscopy, IR spectroscopy, fluorescence analysis and NMR. Other techniques like mass spectroscopy, Raman spectroscopy, ESR are also employed for drug analysis. UV visible spectroscopy is an absorption technique. Here measurement of light absorption by a substance in a wavelength region from 190 to 900 nanometers occurs, where 190 to 380 nanometers covers UV region and 380 to 900 nanometers in visible region. For example, crude drug quercetin absorbs maximum light at the wavelength of 255 nanometers, that is lambda max value. Similarly, lobelia, strychnine, brucine, morphine, these are the drugs absorb light at their specific wavelengths. Hence, the drugs can be evaluated using their lambda max values. Infrared spectroscopy. IR is the study of reflected, absorbed and transmitted radiant energy or light by an organic molecule. They absorb radiation wavelength ranging from 700 nanometers to 1 millimeter, which causes vibrational transition in the molecule. This technique is applicable for identification of phytochemical constituents based on their functional groups. Fluorescence analysis. The organic molecule absorbs specific wavelength of light and remit the absorbed light. This phenomenon is known as luminescence. Fluorescence is a kind of luminescence where emission of radiant energy by the molecules immediately after absorption of the light. This emitted light usually has higher wavelength than that of the absorbed light. This phenomena of fluorescence can be utilized for crude drug evaluation. For example, violet color fluorescence of rhubarb and purple color fluorescence of cinchona are used for their estimation. Nuclear magnetic resonance spectroscopy. Absorption of radio frequency energy by a substance held in a magnetic field. This is due to interaction of radiation with nuclear magnetic momentum. Different frequencies of radiation is absorbed by nuclei with chemically diverse environment. NMR is a tool for molecular structure elucidation, and it is used for identification of impurities and also discloses the position of protons in a complex molecular structures like proteins, alkaloids, etc. Chromatographic methods. These methods would be most useful to identify and quantify the presence of a known impurity in a drug substance. Techniques like TLC, HPTLC, GC, column chromatography, gel formation chromatography, affinity chromatography are extensively used for crude drug evaluation. Move on to non-instrumental techniques. These are majorly divided into two classes based upon the chemical reaction: volumetric analysis and gravimetric analysis. Volumetric analysis, where volume of the solution is measured during analysis. In gravimetric analysis, weight of the substance is considered. Volumetric analysis is a quantitative analytical method which determines the volume of a standard solution which is required to react quantitatively with analyte solution. Analyte solution is the solution whose concentration is to be determined. Titration is a process in which addition of standard reagent to an analyte solution takes place until the reaction between these two solutions is judged complete. So generally, standard solution is taken in the burette and standard solution is solution whose concentration is known. Analyte solution is usually taken in a conical flask. Neutralization titration. These titrations are meant for evaluation of acidic or basic substances. In these titrations, chemical reaction is neutralization reaction. That is, when an acid solution is added to a basic solution or when a basic solution is added to an acidic solution which leads to neutralization. This is represented in the equation as the reaction between H plus ions and OH minus ions leads to production of water molecule. These neutralization reactions are of two types, acidometric titrations and alkalimetric titrations. Acidometry is titration which is meant for determination of alkaline substances where titration with the standard acid occurs. In alkalimetric titration, titration with the standard base takes place. Example for the acidometric titration is, if you want to know the concentration of given sample of potassium hydroxide solution, we have to titrate this solution with the standard solution of hydrochloric acid of known concentration. Example for the alkalimetric titration is titration of acetic acid with standard sodium hydroxide solution. Precipitation titration. These are meant for determination of halides. These titrations are based upon formation of insoluble compound, that is precipitate in the titration process due to addition of titrant to an analyte solution. Here potassium chloride is an analyte and silver nitrate is a precipitating agent, that is standard solution. So the reaction between potassium chloride and silver nitrate takes place to produce a insoluble compound, that is silver chloride, which is appeared as precipitate in the solution. For determination of endpoint in the precipitation titration, there are three methods: Morse method, Ulhart's method and Fazen's method. Complexometric titrations. These are meant for determination of metal ions. In complexometric titration, analyte forms a complex with the titrant. Endpoint is determined by formation of colored complexes with metal indicators. Inorganic compounds of divalent, trivalent ions such as calcium, magnesium, aluminium, iron, etc. forms a soluble complexes with chelating agents such as EDTA. Oxidation reduction titrations. These are also called as redox titrations. These are meant for determination of oxidizing substances or reducing substances. These titrations are based on oxidation and reduction reaction between analyte and the titrant. What is oxidation? It is a process in which removal of electron from anion or neutral species takes place. Whereas in reduction, acceptance of electrons by ions occurs. Coming to gravimetric analysis. Gravimetric determinations are based on measurement of weights. It is the method of analysis in which the compound is to be analyzed is separated from the sample mixture and then weighed. This separation can be attained through precipitation, by chemical reaction, or by volatilization of volatile compounds, or by removing the unwanted materials by heating to a constant weight. For example, lead acid can be used as precipitant to precipitate heavy molecular weight organic compounds such as proteins, alkaloids. Gravimetric analysis is not a single step process. It involves sampling, where obtaining the sample for analysis, then dissolving the sample in a suitable solvent, then addition of precipitating agent to form precipitate, then completeness of precipitation, then digestion of precipitate to form large crystals, filtration of precipitate to separate from mother liquor and to remove unwanted impurities, and washing the precipitate to remove impurities, drying the precipitate to a constant weight, weighing the precipitate in an analytical balance. From the weight obtained here using gravimetry factor, the amount of analyte present in a given sample is calculated. So this is the way the drugs can be evaluated by various methods.